If you just got here, we're working on a problem. A few of you just showed up here right now. So go ahead and hold on one second, guys. I'm just going to flash it back. If you just got here, get your phone out, take a picture of the screen right here. This is the problem we are working on. So if you just got here, I'll leave it up for about 10 seconds. Take a picture with your phone. And we're currently working on A, B, and C. All right, back to our problem, A, B, and C. All right, so what we got. So part A. All right, so question says, what do we know here for sure? We know they didn't tell us a whole lot, right? So the things we know, let me write them off to the side real quick. We know G of 5 is equal to H of 5, and both of those are equal to 1. And we know that Y equals 1 minus 5/3 x minus 5 is tangent to both the graph of G at 5 and H at 5. So let's write this a different way. That's like saying Y minus 1 is equal to negative 5/3 x minus 5. These are the same equation. And it's tangent to G and H at 5. So we'll come back to that, but you can see that that's going to involve telling you that like G prime of 5 is something, H prime of 5 is something. So let's come back to that and see where we go. All right, so the first question for part A said, find the slope of the line tangent to the graph of F. Am I reading the right question? Oh, no, I'm on the wrong question. Sorry. G prime of 5 is our first question. G prime of 5. All right, so who wants to talk to me? What do we got?
You just used the slope from the equation for the tangent line they gave you, so it's negative 5/3.
Yeah, so all we really need to say for this, as far as I'm concerned, is G prime of 5 is equal to negative 5/3. I don't really even think we need to justify anything because they just told you point blank what it was as long as you understood it. So I don't think your justification would be because you told me. There's nothing to really write after that. So that's all for part A. All right, part B says, all right, we've got B of X is equal to 2x squared G of X, 2x squared G of X. All right, write an expression for B prime and find B prime of 5. So we got two things here. One thing, two things. My two things are being multiplied together. So if we're going to be getting a derivative out of this, we are going to be taking a product rule. So this would be first derive the second plus the second derive the first. All right, and into that now it asks you to find B prime of 5. So let's see what that takes us to. B prime of 5 is equal to, so if we put a 5 in here, that's going to be 50. 5 squared is 25 times 2. G prime of 5 plus G of 5 and then times 20. Now we can't stop there. We got to replace the G of 5 and G prime of 5. And as soon as you do that, you can stop after that if you want. So B prime of 5 is equal to 50 times, all right, G prime of 5, we did that in part A. That's negative 5/3 plus G of 5. They tell me that, right? Isn't, yeah, we knew up here, G of 5 is equal to H of 5, and both of those are equal to 1. So we know that G of 5 is equal to 1, and then that gives us 20. If you feel compelled to do that math, feel free, but you can stop right there. Any questions on part B?
I have a question for part A. What does it mean by like the line y equals whatever is tangent? Like, what does that mean?
Tangent, so that's the same thing. That's a synonym for this, the derivative is. So like if I tell you, okay, here's a graph, that's the graph f of x. And at 4, if we have a tangent line there, the slope of that tangent line is the same thing as saying f prime of 4. Agreed?
Yeah.
That tangent slope is the same thing as f prime of whatever. So if I asked you, if I told you there's a line tangent to the graph of f at 4 and its tangent slope is 3, that's the same thing as saying f prime of 4 is equal to 3. They're just telling you what the tangent slope is. That's just a wordy way of saying, hey, here's f prime or whatever. Or in terms of the problem that you have, here it's just a different way of saying, hey, that's what g prime of 5 is. Does that make sense?
Yeah, thank you.
Okay. All right, part C, what we got? W of x, let's get a new piece of paper. W of x is equal to 3h of x minus x over 2x plus 1. All right, write an expression for w prime and find w prime of 5. Okay, so w prime would be a quotient rule. So this would be bottom, derive the top would be 3h prime of x. Now, usually when we do these, it's trig prime, stuff prime. Usually there's something in here that you need to derive. You should be able to hopefully just look at this and go, stuff prime's 1, we're okay. So 3h prime minus 1 from that derivative. So bottom derive the top minus the top derive the bottom over the bottom squared. Okay. All right, we need to plug everything in now. It says to find w prime of 5. So w prime of 5 is equal to, that's going to be 11. 3h prime of 5, I'll just write it out, minus 1 minus 3h of 5 minus 5. I'm putting in 5, right? Yeah. Times 2 over 11 squared. All right, so now you need to just look up h prime and h. So what do we know here? H of 5 is given to us, right? H of 5 is 1. G of 5 is h of 5, and they're both 1. So this one right here, I'm going to scratch it out. I'm going to put a 1. And then we need h prime of 5. What did they tell us about that? That line they were talking about, it was tangent to both the graph of G and H at that spot. So are we on board with this also being negative 5/3? So this one right here would be negative 5/3. And that's it. You're done. No point in doing that math. You've got credit right there. Okay. Any questions, guys? A, B, and C. Are you starting to feel a little more comfortable, hopefully, doing these? A lot of patterns starting to pick up, same kind of stuff. All right, so let's go back and do a little reading now. Let's see. All right, here we are. So now we're going to break this down and look at D and E. All right, so I'm going to read them to you, give you some clues, and I'm going to give you a little bit of time to play with it so that you're familiar with it, and then we'll talk. For part D, it tells you that m of x is equal to d dx. What does that mean? D dx is the derivative of. So m is equal to the derivative of this thing. Find m prime of 2.5, okay? And then the other one talks about the mean value theorem. So I'm not going to give you a lot of time because I think I got to do some teaching here, but I'm going to give you a couple of minutes to just kind of play around with it, see what you come up with, and then we'll talk. So ready, go. Okay, give you about another 1 or 2 minutes, then we'll talk. All right, so let's see what we got here. These ones are a little aggressive, to be honest. So, all right, we got m of x is equal to d dx 0 to 2x g of t dt. We're looking for m prime of 2.5. All right, so first things first, I got to teach you something. So, but in order to do this, so we've done some of these problems before, we were looking at them as like g equals integral f, something like that. And then usually it was like that for bounds or something. And then when you take the derivative of this, it gets rid of the integral and you plug in the algebra bound. You've been doing that all along without really realizing it, because I just write this out for you like that. G prime is equal to f. Okay. So when you have g equals integral f or anything of that nature, and when you take its derivative, you wash out the integral, you plug in the bound that has algebra. Now there's another step to that. We just haven't done it yet. And you multiply by the derivative of the bound you plugged in. There's a messy proof as to why this is, but it's not really worth going through. It's a mess. And you multiply by the derivative of the bound you plugged in. So in this example, that means nothing. But if you have this, if g equals integral f, and we're going from 0 to 3x, whenever we plug this in for g prime is going to be f of 3x times 3. Okay. All right. So does anybody have any questions on that first? All right. So now with that information, give you a couple of minutes, m prime of 2.5. Off you go.
Could you show the paper you just moved away for like 2 seconds? I just want to make sure I wrote it down correctly. Perfect, thank you.
Okay, so if we look here, this is going to be m prime at 2.5. Well, before we get to m prime at 2.5, let's just get to m prime. So m prime of x is equal to, okay, this function says d dx, take the derivative of. So we're not ready to take m prime yet. We need to simplify what we have here. So m of x is the derivative of this. d dx means take the derivative. So to me, m of x is equal to, this says take the derivative. So this would be g of 2x times 2. That is the same thing as m of x. d dx is another way of saying the derivative. So now when we derive this, m prime of x, that's really going to be 2g prime 2x times 2, trig prime stuff prime. And then if we clean that up, m prime of x is really equal to 4g prime of 2x. All right. And now you're being asked to find m prime of 2.5. And that is equal to 4g prime of 5. Well, that's good news because we know g prime of 5. G prime of 5 was from up above. That was negative 5/3. And I am going to suggest we do this math because I have a hunch we're going to need to use it again. So m prime of 2.5 is equal to negative 20/3. Questions, comments, thoughts? Where's our heads at? That's a little tricky, but I think if you process it for a minute, should sink in. So just kind of read through it again, see if it makes sense.
Can you explain again when it is we like multiply it by the derivative of the thing?
When we do the bound, you mean?
Yeah, like when we pull the 2 out, that's when we.
Yeah, so the rule is like, let's do something, I don't know, let's do something you can wrap your head around. I don't know, let's say G is equal to the integral of x squared from 0 to 2. Okay, and I'm telling you that the derivative from 0 to x squared. So, and I'm telling you that when we take this derivative G prime is going to just be what you have inside here, x squared, but you're going to be multiplying it by the derivative of the bound you have. That's not a good example. I did too many x squareds, so that's confusing. Let me try that again. G is equal to the integral of, just go f of t, and it's from 0 to x to the third. So when you take this derivative, G prime is going to be, the integral is gone. We plug in the x to the third. So now you have f of x to the third. And if your bound is more than x, you're required to multiply by the derivative of that bound.
Okay, and that's only used when there's a
That's it.
variable. Okay.
That situation right there. Yeah. You'll kind of know it when you see it. It's very like unique. It's not a one that's going to be used all that often. Like if you're taking the derivative of an integral and one of the bounds is more than x is what we're talking about.
Okay. Thank you.
Could you explain how we got from the first mx to the second mx?
Yeah, so this was a weird, I don't know that I've ever seen one written like this, really. They give you the original function, and the original function says d dx 0 to x. That's the original function. So when we're looking at the original function, this is like the same thing as if your function said m of x is equal to 5x plus 3x. You would probably say, wait, I'm going to do that math. It's 8x, right? For whatever reason, they're calling this 5x plus 3x instead of like putting it together for you. And instead of 5x plus 3x, d dx means the derivative of this. That's actual calculus notation. We don't really use it that much because you're just saying take the derivative. But if you write d dx, like if you look in your calculator, the button you hit to take a derivative at math 8 or math 9, whichever one it is the d dx one. So this is literally the same thing as saying, take the derivative of what you see. So all we're doing is simplifying m of x. So I take this derivative, and that is, based on what we just talked about, g of 2x times 2. That is the simplified version of m of x. And then we take the derivative, which follows the trig rule. So it's trig prime, stuff prime. And then when we plug in 2.5, it gave us 5, and we already knew that one, so we were okay.
Oh, so what I was getting confused on was okay, because we have to basically not take the derivative twice, but we almost have to take the derivative twice to get to m prime of x, because you already have to take the derivative once.
Correct.
Okay, great. Thank you.
Can we practice a couple more of these, or is it like not going to show up a lot?
I mean, it's going to pop up somewhere, but that's really all they're going to look like. So, I mean, if I tell you, g of x is equal to the integral of f of t dt, we can put whatever we want in here from 0 to x to the fourth. And I tell you to take the derivative of this, g prime is going to be, get rid of the integral, plug in the bound, derive the bound. It's just like a small situation that kind of pops up.
Okay. What is this like called? What is that like rule called?
Integrating with bounds that are messy. I don't know. I don't know. Integrating with bounds that are.
Have variables?
You could try that if you're searching. Sure. I don't have an exact name for it. Yeah, you could try integrating with bounds, with algebraic bounds. Maybe that would be a good keyword because the bounds are some sort of algebra. Those would be the searches I would give it a try with. You'll know it when you see it. This will pop up a few more times down the stretch as we're working on problems.
And then if you took the derivative, if you did a second derivative of this, you do product rule.
Yeah, if we had to take another derivative, yeah, this would be first thing, second thing.
Great.
And then you would go through and go from there. Yeah.
Awesome. Thank you.
Okay. Other questions, guys? What's up? Okay. So let's see. Is that a good stopping point or do we keep going? I don't know. Let's see. How much do we have left? Okay, we've got a messy mean value theorem. We've got L'Hopital's rule. I got to teach a G. I got to teach an E. That's going to take us a while. All right, so next week I'm going to finish that. So we'll pause on that for right now. And then, all right, so since it's Thursday, that's it for this week. Give me a second here. Let's look. I want you guys to do some stuff over the weekend for sure. So let's figure out what that something is. Give me a second here. Let's see, do we know how to do all this? I think we do. Okay. Yes, we know how to do that. Okay, so I'm going to pull it up for you guys. I'm going to read through it. We're going to give you a 6-part question for homework. I think we know how to do all of it. Okay, here we go. So this will I'll post it to Canvas here in a second, but let's just read through it just to give you an idea of what we're looking at. So if you want to write any notes or things down, just like write down little, just thoughts, notes, clues, hints, whatever. All right, for number 1, you have a box problem. So for the box is f prime, by the way. And it says the function f has the derivative f prime, yada, yada, yada. Okay, here's a piece of information. F is 0 is 3. For f prime, the conditions of the mean value theorem are met on the interval 0 to 3. Okay. The conclusion of the mean value theorem over the interval 0 to 3 for f prime is satisfied at c is equal to 1. Find f double prime. Okay, so without giving it away, you guys have to graph this, look at mean value theorem, think about what it means when they say it's satisfied. They tell you the slope of that line. See what you can piece together with that. Part B should be easy, right? Use a Riemann sum to approximate 0 to 5 f prime of x dx. Is this an over and under approximation for f prime of x? Keep in mind, we have f prime of x. That's what you already have. So you're just doing a Riemann sum and talking about is it over or under. All right, C, we've got the function f has the derivative. Yeah, this is the same directions. Okay, evaluate this, f double prime. Guys, that is u substitution. So do a u substitution and see what you come up with. If you integrate f double prime, you ought to be coming back to f prime and then see what that does. But u substitution for C. All right, D. It is known that this can be evaluated using L'Hopital's rule. Now, this is a different way of phrasing the question. We've done L'Hopital's rule, but you always were on the hook for figuring out that it was 0 over 0. This one is telling you that when I plug in 0, I get 0 over 0. They're telling you that point blank. Find the limit for the problem. So you're going to use L'Hopital's rule, which is going to be, we're going to take the derivative of the top, we're going to take the derivative of the bottom, and you're going to plug it in again. Now, there's going to come a place, though, where you need to figure some stuff out. For example, if you need to figure something out, you can solve it in the original equation. Since you know plugging this in gives you 0 over 0, we can say when I put 0 in, the top is 0. When I put 0 in, the bottom is 0. So for like example, if I put in 0, f prime of 0 plus 1 is 0. So that would tell me f prime of 0 is equal to negative 1 if I solved that out. Does that make sense? If I can set this top and bottom to 0, when I plug in 0, that would mean f prime of 0 plus 1 gave me 0. So then if I subtract 1 from both sides, you can make the conclusion that f prime of 0 is equal to negative 1. You need that somewhere in the problem. All right, and let's see what we got for this one. We've got E and F. Looks like a quotient rule of sorts. And nice, a differential equation. dy dx is equal to this stuff. Split your variables. All the stuff you need is there. So 6-part question. I would say, I don't know, give yourself 30, 40 minutes to do it. So it's not a huge assignment, but you should be able to knock this out in 30, 40 minutes, something like that. Okay. All right. Do we have any questions?
What does it mean when it tells you that the equation is twice differentiable?
That's just math gibberish. So I try to steer you guys away from that truthfully. Twice differentiable means you can take the derivative twice. I've never seen them give you something that's not twice differentiable. So if something's twice differentiable, that means it's just telling you all the good stuff. Your function's continuous, it's differentiable. It's basically their way of saying, hey, you don't have this for a graph. You don't have anything to worry about. There's no problem spots. Nothing's going to blow up. There's no things that are undefined. It's basically just the math way of saying this thing will work for you. It can be derived all over the place. It's continuous. There's no hurdles, no bumps, nothing wrong with the problem. But like for what you're interested in, doesn't really mean much. You're never going to do anything with it. It's just almost every problem starts off with that. It's just like what they're required to say so that the problem's like technically accurate. But for what you care about, you don't really care about that. Okay. All right, guys, enjoy your weekend. Message me with questions. I will post this here in a second. Okay.
Thank you. Have a great weekend.
Great. See you guys.
Thank you.
You're welcome. See ya.